This is problem 1. We are looking for I, or the ampere. We know that this resistor is in parallel with this one is in parallel with this one is in parallel with this one, and this one is in parallel with this one. So therefore we named it R1, R2, R3, and R4, and all of them are going to be equal to each other because R just equals 12 ohms. So when we do the parallel, we get 6 ohms. So then we get this equivalent circuit here. From here, we can see that this one is in series with this one is in series with this one, so we name them R5 equals R6, which means that it's 12 ohms because it's 6 ohms plus 6 ohms. From there, we get this equivalent circuit where we have 12 ohms in parallel with the 12 ohms. So therefore we name this R7, which gives us 6 ohms. From there we get this circuit where we can see that the 6 ohms is it's in series with the 4 ohms, so then we can just use the I equals voltage over resistance, which is I equals 20 volts divided by 10 ohms because these are in series, so we get 2 amps.
So this is problem 14, and in this problem we had to find the impedance Z of the circuit when omega was equal to 400 radians a second. So this is our circuit that we have. We have a resistor, a capacitor, an inductor, a resistor, and then another inductor. So the first thing that we have to do is we have to find our Z values. So your Z value equations can be found on your handout that you got in class. They're right here. So Z of R1 is just the resistor value. Z of C1 is just plug that into the formula and you get negative J over 1.25. ZL1, use the formula again, you get J of 1.2. ZR2 is 5. ZL2, using the formula, is J times 3.6. And then that's all of your Z values. And then you can draw an equivalent circuit with showing your Z values. So after that, you solve this just like it's a normal circuit, like these are in parallel and then these are in series. That's just what you do to solve this. So for your first Z equivalent, these two, ZR2 and ZL2, are both in parallel. So once you use the formula for parallel Z's, you get J18.5 plus J3.6. After you get Z equivalent 1, you combine Z equivalent 1 in series with ZL1 to give you Z equivalent 2, and that gives you 1620 over 949 plus 100 plus 16,944 over 4,745J. After you do those two, you can redraw the circuit again. ZEQ2 is here, ZC1 and ZR1. So you can find ZEQ3 by combining ZC1 and ZEQ2 in parallel. So once you do that, you get ZEQ3, and the formula is all of this right here. So ZEQ3 is equal, and then you have ZEQ4, sorry, I wrote that wrong, is equal to ZR1 in series with this right here. So I just left this in my calculator, and this is what I came out with. ZEQ5 is equal to 5.32133 minus 1.68688J.